Hey everyone, welcome back to Drive District. And now, finally, it's time for the long-awaited top 10 most unreliable diesel engines. Diesel engines are supposed to be reliable and built to last. People buy diesel-powered cars for high mileage, heavy use, and fuel economy. After all, a diesel engine generally uses less fuel than a gasoline engine. But the race for better efficiency, lower emissions, and simply cheaper production has made modern diesel engines increasingly complicated, and in some cases, seriously unreliable. So today, I've put together my top 10 most unreliable diesel engines. Let me make one thing clear right away. The engines in the first half of this ranking can get you into trouble mainly because owners don't understand their specific weaknesses and maintenance requirements. The engines in the second half are here because engineers made some genuinely unfortunate design decisions. Alright, let's get into it.
Number 10. Mazda 2.0 MZR-CD. At number 10, I've placed the 2.0-liter Mazda MZR-CD diesel. Now, this isn't a bad engine. It uses a common rail fuel system with the fuel injection equipment supplied by Denso. In fact, this engine is basically a heavily modernized version of Mazda's diesel engines from the 1980s. And that's exactly where the problem starts. The first version became surprisingly complicated. It was equipped with 7 electro-vacuum valves controlling the EGR system, intake throttle, turbocharger actuator, and various other components. In other words, this engine was absolutely covered in hardware. And there's another problem. This diesel can easily dilute its engine oil with fuel. That can happen because of frequent and unsuccessful DPF regeneration cycles, as well as fuel leaking from the return lines. It's also surprisingly easy to miss a problem with the fire sealing washers underneath the injectors. Why? Because the injectors are located underneath the valve cover.
If those sealing washers start leaking, combustion gases can enter the space underneath the valve cover and contaminate the engine oil. The fuel system itself is reliable, but if any individual component fails, the repair bill can get expensive very quickly. On top of that, not every mechanic is familiar with this particular engine, which makes diagnosis and maintenance even more complicated. So, the Mazda diesel isn't necessarily a bad engine. It's just too complicated for its own good. And that's why the Mazda 2.0 MZR-CD takes number 10 in my anti-ranking. Let's keep going. Number 9. BMW N47 and N57. At number 9, we have a modern BMW diesel family whose reputation was seriously damaged by some questionable cost-cutting decisions involving some very important components. In 2007, BMW introduced 2 new diesel engines, the 4-cylinder N47 and the 6-cylinder N57. These were high-tech engines built around an aluminum cylinder block.
But many of them ended up in repair shops surprisingly early because of rattling and strange noises coming from the engine. And in many cases, those noises were coming from the rear of the engine, around the 4th cylinder. Some engines started doing this with as little as 50,000 kilometers on the clock. Eventually, it became clear what was making the noise. There were 2 timing chains and the oil pump chain, all located on the transmission side of the engine. BMW replaced chains under warranty, redesigned the timing chains, and improved the tensioner. But unfortunately, many engines had already been affected. One of the timing chains could jump, leading to extremely serious engine damage. The oil pump chain had a similar problem. If it failed, the oil pump stopped turning, oil pressure disappeared, and the engine could suffer catastrophic oil starvation.
And here's an interesting detail. To replace all 3 chains on the BMW N47, you don't necessarily have to remove or suspend the engine. You can remove the transmission, gain access to the timing system, and replace the chains from there. The N47 can also suffer from cracks in the cylinder block between cylinders 2 and 3. The first and second cylinders can also experience overheating, although these failures are relatively uncommon. On the bright side, the swirl flaps in the N47 are much better secured than they were on its predecessor. And even if a swirl flap somehow ends up inside a cylinder, the engine should not suffer catastrophic damage from it. Overall, the N47 demands serious attention to its 3 critical chains, and that's why it takes number 9. Number 8. 2.0 TDI PD. At number 8, we have the 2.0 TDI with unit injectors. This was a Volkswagen Group diesel used across pretty much every brand under the VAG umbrella. And right away, we need to point out that there were several different versions of this engine, and those differences determine what kind of problems you're going to face.
These engines could come with either an 8-valve or 16-valve cylinder head, and with or without balance shafts. All longitudinal versions of the 2.0 TDI, along with some transverse versions, were equipped with balance shafts. The balance shafts were driven from the crankshaft either by gears or by a chain, and one of those balance shafts also drove the oil pump using a small hexagonal drive shaft. Owners affectionately nicknamed this little part the pencil, and the pencil did a great job, at least until the warranty expired. It would usually survive around 100,000 kilometers. After that, the hexagonal shaft could wear down, the oil pump would stop turning, and oil pressure would drop. If the driver didn't shut the engine down immediately, the result could be a completely seized engine. It wasn't until 2009 that engineers finally reinforced the shaft and increased its length from 77 mm to 100 mm. And here's the funny part. A similar pencil design was also used on some newer 2.0 TDI common rail engines. But the problems don't stop there. The 2.0 TDI also developed issues with its cylinder heads. On the 8-valve versions, the unit injectors could damage their mounting seats. On the 16-valve versions, cracks could develop in the cylinder head. A huge number of defective cylinder heads were produced before 2008. The unit injectors themselves are generally reliable and can last a long time, but they're notoriously difficult and expensive to repair, especially the piezoelectric versions. The balance shafts can also become a problem because of worn bearing journals and damaged drive gears. And diesel fuel can end up contaminating the engine oil due to worn seals inside the tandem pump. In other words, the 2.0 TDI and its earlier 1.9 TDI unit injector predecessors have quite a few weak points. That's why the 2.0 TDI earns number 8 in our ranking. Let's keep going. I've put an old-school, purely German 2.2 DTI engine in 7th place. This engine was designed for Opel and Saab vehicles. It first appeared in 1997 and featured direct injection with a Bosch BP44 rotary injection pump. This diesel can easily make it to 500,000 kilometers, but there are a few things you need to know if you want to avoid an expensive repair bill. The most troublesome component on this engine, and the one that often needed to be replaced or repaired, was the PSG-16 injection pump control unit. There's a transistor inside this unit that controls the fuel delivery valve. If that transistor burns out, the engine simply won't start. The mechanical part of the Bosch BP44 injection pump, on the other hand, is reliable and relatively easy to repair. This engine can also develop air leaks in the fuel system or even pull engine oil into the fuel system through worn seals on the fuel supply fittings. When that happens, you can get serious problems with both starting and engine operation. The timing chains have a pretty impressive service life and can last around 300,000 kilometers. Unfortunately, many of these engines eventually died because pieces of the swirl flaps got into the cylinders and ended up under the valves. There were also quite a few cases of crankshaft failures. The general opinion is that the crankshaft is one of the weak points of this engine. It also drives the balance shafts, which puts additional stress on it. So, that's our 7th place engine. Let's keep going. In 6th place, we have a particularly troublesome Renault diesel. Here's the thing, Renault had two very similar engines in this family, the 2.2-liter and 2.5-liter G9T and G9U. The smaller engine was used in larger passenger cars like the Renault Laguna and Espace. The bigger version was mainly used in Renault commercial vehicles. Both engines use a common rail fuel system. So, what's wrong with them? Well, they're simply too complicated. Almost everything about these engines is unnecessarily complex. You've got complicated swirl flaps, a complicated alternator, and a complicated combined timing drive with a whole collection of gears and a toothed belt. Sooner or later, practically every one of these components will need attention. The self-adjusting timing gears can wear out and start filling the engine oil with metal particles. The bushing inside the combined gear assembly, which also carries the pulley for the timing belt, can wear out as well. And when that happens, you can end up with an oil leak. The oil pump is another weak point on this engine. The pressure relief valve can stick. The drive shaft can wear out. And you can also get excessive wear between the oil pump gears and the pump housing. The main and connecting rod bearings react almost immediately to a drop in oil pressure. And once the oil pressure gets too low, the bearings can literally weld themselves to the crankshaft. The engine seizes and you're looking at an extremely expensive repair, or even a complete engine replacement. One way to prevent this problem is to install a separate mechanical oil pressure gauge. You can also reduce the oil change intervals. So overall, the Renault 2.2 DCI and 2.5 DCI turned out to be seriously problematic engines, and they're still in pretty high demand at auto salvage yards. In fifth place, I've put the 2.0 CDTI engine, best known from Opel vehicles. This engine has Italian roots and was developed from the 1.9 CDTI. And here's the interesting part. It wasn't used only in Opel cars and their platform-sharing Saab models. You could also find it under the hood of Fiat, Alfa Romeo, Jeep and Suzuki vehicles. The 2.0 CDTI turned out to be more complicated and more problematic than its predecessor, the 1.9 CDTI. The older engine could give you trouble with swirl flaps getting stuck or even breaking apart. But the 2.0 CDTI has some problems of its own. For example, coolant can make its way into the intake through a passage running through the intake manifold. This engine can also mix coolant with engine oil because of a failed heat exchanger gasket. But honestly, all of that is nothing compared to the biggest problem. The main bearings can literally seize onto the crankshaft journals. And this can happen because the gasket between the oil pump and the oil pickup tube starts leaking air. That means the oil being sucked up by the oil pump and delivered to the engine's friction surfaces contains air bubbles. Oil pressure and oil flow drop, and the most heavily loaded components stop getting enough lubrication. The protective oil film disappears, and that's when things get ugly. There are also complaints about the pressure relief valve. If it malfunctions, the oil pump can start operating at maximum capacity and actually suck air into the system. This engine has plenty of potential problems, but the biggest and most serious one is still the bearings seizing onto the crankshaft journals. Owners have tried to prevent this by installing an oil pressure gauge to monitor the actual pressure. Some also clean the pressure relief valve and replace the oil pickup gasket before it has a chance to fail. So, fifth place is well deserved. Let's keep going. We're getting closer to the top 3. In fourth place, I've put a diesel engine from Ford. Back in 2000, Ford introduced a family of diesel engines ranging from 2.0 to 2.4 liters. They're not bad engines overall, and they were installed in the Ford Mondeo, its platform-sharing cousin, the Jaguar X-Type, and also the Ford Transit. In 2007, these engines disappeared from Ford's passenger cars and were used mainly in commercial vehicles. You could find them in the Ford Transit, Fiat Ducato, Peugeot Boxer, Citroën Jumper, and even the Land Rover Defender. Before 2007, there wasn't much to complain about. But after 2007, the timing chains became a weak point. They could stretch and eventually break. The problem was especially serious on the 2.4-liter version, where the timing chain has a particularly poor engagement with the intake camshaft sprocket. Then, in 2007, the engine received a lightweight cylinder head with some extremely weak hydraulic lifters. They could wear out as early as 200,000 kilometers. After that, the roller rocker arms could start sitting at an angle, and the corresponding camshaft lobe would begin to wear. It could also cause the cam lobes to hammer against the misaligned rockers. And when that happens, the entire rocker arm and hydraulic lifter assembly can literally get pulled out of the cylinder head. But the diesel became even more problematic around 2014, when Ford started installing a vane-type oil pump. The problem? The vanes were made from some questionable plastic. They could crack, the oil pump would stop working, and this could happen with as little as 30,000 kilometers on the clock. Obviously, the engine would then die from oil starvation. Dealers replaced engines under warranty and installed improved oil pumps. But many owners of these engines still preferred to install the older style pumps. The old gear-driven oil pumps can be installed on later versions of the Ford 2.0 to 2.4 TDCI diesels without any major modifications. So overall, the later Duratorq engines used in Ford commercial vehicles have a pretty questionable reputation. Third place in my ranking goes to the popular French-German 2.7 HDI diesel. This engine was developed as a joint project between PSA and Ford, and production was set up in England. It wasn't used only in French Peugeot and Citroën models. You could also find it under the hood of Jaguar, Land Rover, and Range Rover vehicles. The biggest and most common problem with the 2.7 HDI and the 3.0 HDI as well is the main bearings literally seizing onto the crankshaft journals, along with actual crankshaft failures. This engine caused the most headaches for owners of heavy Land Rover SUVs. If you're a Land Rover fan, this is probably one of the worst engine choices you could make. Not that many of these engines made it into French cars, but even French sedans had their fair share of crankshaft failures. So, why does this happen? Well, the manufacturer recommended the wrong type of engine oil for this motor, a fuel-saving oil that simply doesn't provide a thick enough protective oil film.
On top of that, under certain operating conditions, the oil can reach extremely high temperatures, which obviously doesn't help its protective properties. Many specialists believe this engine should run on a thicker oil. Interestingly enough, that's actually the type of oil recommended for this engine during the first years of production. Now moving on to second place. In second place, I've put an engine designed for big Nissan vehicles, the 3.0-liter Nissan ZD3O. The Nissan ZD3O was installed in the Nissan Patrol, Nissan Terrano, the Navara pickup, and several other models. Originally, this engine used a direct injection fuel system with a Bosch VP44 rotary injection pump. The common rail version appeared in 2007, and early in its life, the Nissan ZD3O became famous for some seriously expensive failures.
Cylinder heads could crack, pistons could literally fall apart, glow plugs could disintegrate, the crankcase ventilation system could become clogged, and the timing chains could break. The engineers worked hard to eliminate these problems. The piston failure issue was largely addressed by 2004. But even after the improvements, this engine still benefits enormously from some preventative upgrades. For a ZD3O-equipped vehicle, it's highly recommended to install an additional lift pump, an oil catch can, and even a fan for the intercooler. It's also a good idea to add gauges for monitoring oil temperature and boost pressure. Some specialists even recommend installing the cylinder head gasket from the later common rail version of the ZD3O. So, that's my second place engine. And it's an engine that forced quite a few Nissan Patrol owners to replace it with the much more reliable 4.2-liter diesel.
And now we've reached the worst diesel engine in the Drive District ranking, the winner of my anti-rating. Meet the Japanese turbo diesel, the Isuzu 3.0 B6 D-Max. Isuzu is a Japanese company that develops its own diesel engines and supplies them to a number of other manufacturers, including quite a few European automakers. Today, we're talking about a V6 diesel that Isuzu supplied to Opel, Renault, and Saab. This engine was installed in flagship models like the Opel Vectra C, Opel Signum, Saab 9.5, Renault Espace, and several others. And this Isuzu diesel is famous for one thing above all else. It overheats, and when it does, the consequences can be extremely expensive. Owners of vehicles with this engine have to constantly keep an eye on the coolant level and monitor all the usual weak points where coolant can leak. Many drivers also avoid revving this engine beyond 3,000 revolutions per minute. Because when it overheats, the aluminum cylinder block can deform around the center cylinders of the cylinder banks. The sealing between the cylinder block and the cylinder heads can also fail. Combustion gases can then get into the cooling system, and coolant can make its way into the cylinders. Even worse, overheating can cause the cylinder liners to move deeper into the block. The most problematic Isuzu 3.0 V6 engines were produced between 2001 and 2005. After that, Isuzu improved both the cylinder block and the cooling system. But even then, quite a few of these engines still ended up being replaced or rebuilt, including repairs involving new cylinder liners. And even after a rebuild, you still have to keep a close eye on the engine temperature. So that's how my anti-ranking turned out.
Do you agree with my list? Or would you rank these engines differently? Let me know in the comments. I'd really like to hear your opinion. And if you want to know everything about cars, engines, transmissions, and parts, make sure you subscribe to the channel. Hit that notification bell, leave a like, and subscribe to Drive District. Thanks for watching.